Have you ever wondered why some projects finish on time and within budget, while others drag on for months and cost way more than expected? The secret lies in something simple but powerful: project scheduling. 1. What is project scheduling? At its core, project scheduling is the process of organizing tasks, resources, and timeframes to ensure that a project is completed efficiently. It's like a roadmap that guides you from start to finish, highlighting all the critical steps along the way. When you break down a project into manageable tasks, you can prioritize, assign deadlines, and keep the entire team aligned with the overall goals. Without a schedule, even the most well-planned project can quickly fall apart. 2. Why is project scheduling important? Now, why does scheduling matter so much? First off, it creates structure. Imagine building a skyscraper. You can't pour concrete before laying the foundation, and you definitely can't install windows before the walls go up. A well-defined schedule ensures tasks happen in the right order, avoiding chaos and rework. But that's not all. Scheduling helps to track progress, manage resources, and identify potential risks before they become major problems. When a task is delayed, you can adjust the timeline to minimize the impact on the rest of the project. This flexibility is key in keeping things on track. 3. Consequences of poor scheduling. On the flip side, poor scheduling, or no scheduling at all, can be disastrous. Without a clear plan, deadlines can be missed, budgets can skyrocket, and team morale can plummet. Think about it: when no one knows what to do next, confusion sets in. And confusion often leads to mistakes. Projects can run over budget, over time, and, worst of all, fail to meet the expectations of clients or stakeholders. It's like setting off on a road trip with no map or GPS. You might eventually reach your destination, but you'll waste time and resources along the way. How to create an effective schedule. So, how do you create a schedule that works? Start by identifying all the tasks that need to be completed, from the smallest to the largest. Next, assign deadlines to each task, keeping in mind dependencies. Some tasks must be finished before others can begin. Don't forget to allocate resources, whether that's manpower, equipment, or materials. Regularly review and update the schedule as the project progresses. This keeps everyone informed and allows for quick adjustments if something unexpected comes up. A flexible schedule is a successful schedule. The power of scheduling. In the end, project scheduling isn't just about timing. It's about coordination, communication, and control. With a solid schedule in place, you can steer your project toward success, delivering results on time, within budget, and with less stress. So next time you're faced with a big project, remember, the schedule is your best friend. When you gaze at a towering skyscraper piercing through the clouds, you might think its biggest battle is against gravity. But there's a silent force constantly at war with these giants: wind. This invisible enemy can make or break a tall structure. Welcome to Understanding Wind Loads, the silent enemy of tall structures. 1. What are wind loads? Wind loads refer to the pressure and forces exerted by wind as it flows around a building. The faster the wind, the more force it applies. But it's not just a steady breeze we're talking about. Wind is unpredictable. Gusts can slam into a building from different angles, creating areas of high pressure on one side and suction on the other. Tall structures, like skyscrapers, experience these forces more intensely. The higher you go, the stronger the wind, and this can create problems if not properly accounted for during the design process. 2. The danger of wind-induced vibrations. One of the biggest dangers of wind loads isn't just the direct pressure, but the vibrations they can cause. When wind hits a building at just the right speed, it can create something called vortex shedding. This phenomenon can cause a building to sway and shake, sometimes violently. Without proper design, wind-induced vibrations can lead to structural fatigue, cracks, and in worst cases, catastrophic failure. Imagine a massive tower moving back and forth like a reed in the wind. It's terrifying, but it's exactly what engineers work to prevent. 3. How engineers combat wind loads. But fear not, engineers have developed clever solutions to fight back against wind. One of the most common tools is the use of aerodynamic design. Rounded corners and tapered tops help reduce wind pressure and keep the structure stable. Another brilliant technique? Tuned mass dampers. These are giant weights placed at the top of a building that sway in the opposite direction of the wind-induced movements, counteracting the vibrations. It's like a balancing act at a massive scale. Some buildings even use perforated exteriors or gaps in the structure to let the wind pass through, minimizing pressure and turbulence. These design tricks turn wind from a fierce enemy into just another factor engineers can control. 4. Why wind load matters to you. So, why does this matter? As we continue to build taller, wind loads are becoming an even bigger challenge. And in a world dealing with climate change, stronger storms and unpredictable weather patterns mean wind loads could become more dangerous than ever before. Whether you're an engineer, a student, or just someone fascinated by skyscrapers, understanding wind loads gives you a glimpse into the invisible battles that happen every day above our heads. The next time you look at a skyscraper, remember, it's not just standing tall by chance. It's fighting the wind and winning. In the silent war between wind and structure, engineers are the unsung heroes, ensuring our buildings withstand the forces of nature. So, the next time you see a skyscraper, know that it's more than just steel and glass. It's a testament to human ingenuity. Welcome to today's discussion on an exciting and transformative topic in the construction industry, the role of robotics in modern construction. As we dive into this subject, we'll explore how robotics is reshaping building practices, improving efficiency, and enhancing safety on construction sites. 1. The evolution of robotics in construction. Robotics in construction isn't a new concept, but its application has evolved significantly over the years. Initially, robotics focused on simple tasks, such as material handling and basic assembly. Today, however, advanced robotics can perform complex tasks, from bricklaying to even autonomous vehicle operations. This shift has been made possible by advancements in AI, machine learning, and sensor technology, enabling robots to work more intelligently and adapt to various environments. 2. Benefits of robotics in construction. The benefits of integrating robotics into construction processes are numerous. First and foremost is efficiency. Robots can work tirelessly, completing tasks faster than human workers. For instance, robotic bricklayers can lay bricks with precision and speed, significantly reducing construction time for masonry projects. Next is safety. Construction sites are often hazardous environments. By deploying robots to handle dangerous tasks such as demolition or operating heavy machinery, human workers are kept out of harm's way. This not only reduces workplace injuries, but also minimizes the risks associated with strenuous labor. Moreover, robotics can lead to cost savings. While the initial investment in robotic systems may be high, the long-term savings achieved through reduced labor costs, minimized material waste, and enhanced project timelines can outweigh these costs. 3. Real-world applications. Let's look at some real-world applications of robotics in construction. One prominent example is automated drones. These drones are used for site surveys, inspections, and monitoring progress. They can quickly collect data and provide real-time insights, allowing project managers to make informed decisions. Another innovative use is in 3D printing. Robotic 3D printers can create entire structures or components by layering materials. This method not only reduces construction waste, but also allows for intricate designs that would be difficult or impossible to achieve through traditional methods. Additionally, companies like Construction Robotics have developed robotic arms that can assist workers in tasks like concrete pouring and surface finishing. These robots enhance precision and reduce fatigue for human workers, increasing overall productivity on the site. 4. Challenges and future prospects. Despite the many advantages, integrating robotics into construction does come with challenges. There are concerns about the high initial costs and the need for specialized training for workers to effectively collaborate with robotic systems. Furthermore, there is an ongoing debate about the impact on employment. While robotics may replace some jobs, they can also create new roles focused on managing and maintaining these advanced systems. Looking ahead, the future of robotics in construction is promising. As technology continues to advance, we can expect to see even more sophisticated robots capable of handling a wider variety of tasks. The integration of AI will likely lead to smarter robots that can learn from their environments and improve their performance over time. In conclusion, the role of robotics in modern construction is both transformative and essential. By improving efficiency, enhancing safety, and reducing costs, robotics is setting a new standard for how we build. As we embrace these advancements, the construction industry is poised for a future that not only enhances productivity, but also prioritizes the safety and well-being of its workforce. Thank you for joining me in this exploration of robotics in construction.